Hello. In this video, we will talk about moles, molar mass, and how do we use them in calculation. In our daily life, we use a dozen, and it means number 12. We use it to make calculation or to make counting actually easier. In chemistry, we have some similar term. We call it a mole. But this number or this term is a very large number, which is 6.022 times 10 to the 23. So when I say 1 mole of matter, I mean by it 6.022 times 10 to the 23 particles. Particles in chemistry could be atoms or subatoms like neutron, proton, and electron. Or it could be molecules. If the compound is covalent, that means every two atoms together or three or more combined with a bond. Like, for example, oxygen, O2, when you have two atoms combined together. Water, when you have three atoms combined together, etc. Now, it could be formula units. Formula units, it's for ionic compound. And for example, like the salt that we eat, NaCl. So for ionic, we use formula unit. For covalent, we use molecules. Every two ions here combined together. Ion is a charged particle. So it could be formula unit, and it could be ions alone, like Cl minus, like Na plus, like Mg2 plus, etc. As an example, here I can take 1 mole of carbon atoms. It means 6.022 times 10 to the 23 carbon atoms. If I say 1 mole of water molecules, it means same number of water molecules. If I say 1 mole of MgCl2, it means 6.022 times 10 to the 23 MgCl2 formula units. So what is molar mass? Molar mass is the mass of 1 mole of things. So molar mass, if I see it here for 1 mole of carbon, it's not the same as 1 mole of water. It's not the same as 1 mole of MgCl2. Just like a dozen. A dozen of cars, its mass is not the same as a dozen of pens. So how do we get the molar mass? Molar mass, you can get it directly from periodic table. For carbon, you go to periodic table and you can see that in carbon, we have two numbers. We have 6 up and 12.011 down. So you pick the larger number. The larger number that we have here is molar mass of carbon. So you write carbon molar mass equal to 12.011 gram per mole. For water, it's made up of two elements, hydrogen and oxygen. So you go similarly to hydrogen and to oxygen and you check the numbers. For hydrogen, we have 1.008. For oxygen, it's 15.999, which is 16. So we write, since we have two hydrogen, so we write 2 times 1.008 plus 16, and you will get plus 16, and you will get 18.016 gram per mole. Always we write gram per mole as a unit because it's the gram per 1 mole of matter. How do we use mole, particles, and molar mass in calculation? Let's see. First, we need to write the two relations that we have from these two examples. So the first relation is 1 mole has 6.022 times 10 to the 23 particles. Second relation is 1 mole has a mass, we call it molar mass. Now, a molar mass here, I will write it as in gram. Why? Because we already said that it is 1 mole equal to this grams. So it's a gram per mole. Now, these two, I can change them to conversion factors. So for example, the first one here, I can change it into 2 conversion factors. The second one also I can change it to 2 conversion factors. Simply, I put 1 mole over the number of particles, which is 6.022 times 10 to the 23 particles, or I do the opposite, 6.022 times 10 to the 23 particles over 1 mole. Now, second one, I can do the same. So it's 1 mole over molar mass, and it's in grams, or I do the opposite. 1 mole is down, and molar mass is up. Okay, let's see some examples by which I will use these conversion factors. In this exercise, we need to find the number of moles or particles in each case. So in part A, you can see that we have 1.2 times 10 to the 25 calcium atoms, which is particles. So I need to change it to moles. In part B, I have 3.25 moles of glucose. I need to change it to particles. Now, what do I do and which conversion factor I use? I simply start with the given 1.2 times 10 to the 25 atoms, which it is particles, times. Let's look at the first conversion factor and the second conversion factor. Which one of these, if I put here, I can cancel the old unit, which is atoms, and I have the new unit, which is mole. So if I put the first one, 1 mole over 6.022 times 10 to the 23 particles, which is here atoms, I simply cancel the atom with the atom and I will get the number mole. This will be equal to 19.93 moles. Let's see the second example. Here we have 3.25 moles of glucose. I want to change these moles into molecules. Now you will say, how do I know if it's atoms or molecules or whatever? You can know it from the compound. If the compound is molecular, then, or covalent, then it's made up of molecules. If it's ionic, then it's made up of formula units. Now, if it's not a compound, if it's an element, it's made up of atoms. Okay, so for this one here, I need to cancel the old unit, which is mole, and I need to have the new unit, which is particles. So particles should be up. Particles here will be molecules, and down it will be 1 mole. So molecules here, it is 6.0 from the conversion factor that you can see up. It's 6.022 times 10 to the 23 particles. And the answer is 1.96 times 10 to the 24 molecules. Let's see another example. Find the number of moles or grams in each case. Part A, 28 grams of magnesium. So the given is 28 grams times. I want to change it to moles. So I need to use the other relation where I have mole and gram. I have this, the first one, I have the second one. Now I need to put the old unit down, which is grams, and I need to put the new unit up. Why? Just to cancel it. So 1 mole of, or 1 mole here, over molar mass of magnesium. If you go to the periodic table, it's 24.3 grams. So gram by gram cancelled, and you get 1.15 moles. Now let's go to the second part. We have 5.8 moles. I want to change it to grams. So the new unit is gram, the old unit is mole. So I need to use the second conversion factor here. I put mole down and grams up. Now I have carbon, which is 12.011. Oxygen is 2 oxygen I have here, so it's 16 times 2, 32. Added to 12.011, you will get 44 grams or 44.011 grams. Mole and mole cancel, and the answer is 255.26 grams. The third and last example in this video is find the number of particles or grams in each case. In part A, we have 3.2 grams of glucose molecules. Now, 3.2 grams, I want to change it to particles or molecules in this case. Let's start step by step. 3.2 grams times. If you look at the relations, there is no direct relation between gram and particle. So we need to change gram to mole, then mole to particles. How do we do this? We need more than one conversion factor. So we need one conversion factor from here and another from here. Let's start step by step and let's see which one we need to start with. So the first one is I need to get rid of grams and change it to mole. So I put the molar mass of a glucose, which is 180.162 grams, and I put 1 mole up. By doing this, I cancel the gram with the gram and I get the mole. I don't stop here. I don't want it in moles. I want it in particles, which is here molecules. So I need to put another conversion factor, which is, let's see which one. I have mole up. I need to put mole down to cancel the mole and get the molecules. So I need to take the second one. So 1 mole down and 6.022 times 10 to the 23 molecules up. Then what do? I simply just multiply 3.2 times 6.022 times 10 to the 23 over 180.162. It will be 1.07 times 10 to the 22 molecules. Let's see the opposite case. I have 6.5 times 10 to the 20 particles. I want to change them to grams. So what do I do here? I start always with the given. 6.5 times 10 to the 20 formula units, and I change it into moles. So the first thing and the main thing, always you need to change to mole. So let's look here. So here I have particles down, here particles up. So this is the correct conversion factor, 1 mole over 6.022 times 10 to the 23 formula units times, last one, I need to change into gram. So mole into gram. I choose the second one here because mole is up, so I need to write mole down. And the molar mass of calcium nitrate is, calcium is 40.078 plus nitrogen. Here we have 1 times 2, so it's 2 nitrogen. So it will be 28 plus oxygen is 3 times 2, it will be 6 oxygen, so 6 times 16, so altogether will be 164.078 grams. Now, formula unit by formula unit is cancelled, mole by mole is cancelled, and we will get the answer in grams, which is, it is equal to 0.177 grams. Now, to end this video, you need to take care about two relations. And when you know these two relations, you will know how to convert from one unit to the other. You first start with the given, and the given will lead you So if it's in grams, you want to change to mole, you use the second one. If it's in mole, you want to change to particles, you change or you use the first one. And so on. If you want to do the opposite, you do the opposite way. For more practice, you will find in the description below a worksheet with its answer key, and this video will be followed by another video with tips and tricks of 1.1. See you later.